Okay, so we're doing problem of the day. It's 13th of April 2026. Unfortunately, I missed yesterday's. I looked at it and it did seem quite tricky, but I feel like maybe I could have gotten it, but I don't know, I didn't really have all the time in the world, unfortunately. Um, okay. Minimum distance to target element. They're really liking this minimum distance thing right now. Oh, I think my... Okay, so given an integer array nums, 0 indexed, yes, and two integers target and start, find the index I such that nums at I is equal to target and the absolute value between I and start is minimized. What? Okay. Note that, yeah, I know that. Return that difference, which is the minimum distance. Okay, sure. It is guaranteed that it exists. Okay, well, I mean, if this is my array, and like I have, some elements. And I suppose my start is one of these elements, let's say this one. Then I guess I could just iterate forwards, iterate back, iterate forwards, iterate back until I'm done, right? There's only 1,000 elements? Okay. And what's the smallest size? 1. So there's at least one element. Yeah, that makes sense. And I'm assuming, yeah, start will be a valid index. Okay. Um, hmm. This shouldn't be too bad, right? So current distance equals 0. While I don't know, true. If nums at start plus current distance equals target, so I have to first check if start plus current distance is a valid index, and then return the current distance. If start minus the current distance is a valid index, whoops, and nums at start minus the current distance equals target, then return the current distance. Otherwise, current distance plus equals 1. So I guess I can say while current distance is what, less than the length of nums? Less than or equal to? Less than? And then if I get out of here and I really don't get anything, which shouldn't happen because I just return -1. But I don't think this should ever run. Is that fine? So like, yeah, +1, +1, +2, sorry, +1, -1, +2, -2. There's also +0 as well. +0, -0, which will do the same thing twice, but that's fine. So yeah, if it's at start, if the target is at start, then it will just return. I don't really see where this could go wrong. Is there any particular issues? Like, let's say, what is it? So they give the array and then they give the target and the start. Okay, so let's say I have like this. Right? And then I give a target of like 2 and a start of, say, 7. So actually, oops. So we're starting at 8, index 7. Okay, so it handles that case of like current distance spilling over the page on the positive side. And then finding the target of 2. So we get 6. 1, 2, 3, 4. Okay, I mean, yeah, I don't know where it could go wrong. I don't understand. Okay, I guess it is an easy problem. I shouldn't overthink it. Oh, it's slow. Okay. What's a clever thing I could do? It's not sorted exactly. So I don't think it's like a binary search idea. And surely like for smaller for thingies this small, I think for cases this small in size, I feel like the overhead of like setting up binary search might be more annoying than anything. What are other people doing? Oh. Distance is equal to n. For I in range, if nums at I is equal to target, then current is equal to the distance. Oh, yeah, that also makes sense. Okay. I feel like my thing has early exit though. Like, this guy has to go through the entire array. Whereas I guess, yeah, again, maybe it's just the overhead. The casters are too small. Oh, wow. Well. Okay. Yeah, fair. Okay. Do I want to just try yesterday's problem? I saw this roughly. Seems a bit scary. I only thing that I figured out yesterday was that the greedy solution doesn't work. So this one will be genuinely hard. So 13:20. What's the time? Okay, I can do this for like 40 minutes. Minimum distance to a type. Oh wait, what? To type a word. Okay. So min distance to type a word. So you're given keyboard. I'll just screenshot this. Oh, I can't screenshot. Very good. So A, B, C up to F. So A, B, C, D, E, F. And then do that for G, M, S, Y. Okay, so this is my keyboard. J, okay. So this is my keyboard. And the idea is, yeah, XY plane, whatever. Each, only got uppercase letters for each. So you got coordinates. You got 0, 1, 2, 3, and 4. And you have 0, 1, 2, 3, 4, and 5. So you got 6 columns, 5 rows. Although, obviously, this is like the full matrix, and then you got like 2 extra on the end. For example, A is located 0, 0, B is located 0, yeah, whatever. Given the string word, return the minimum total distance to type such a string. Distance between coordinates is Manhattan distance. Yeah, so we use Manhattan distance. It's just a type of distance metric, basically, between x0, y0 to x1, y1. The distance is this plus this. Basically, if you, for example, think h to q, it's basically how much across do you have to go plus how much vertical do you have to go. So 1, 2, 3, 4. That would be your Manhattan distance. So you can check the numbers as well. X4 minus x0 is 1, is 3, and the y is 2 minus the 1 gives you 1, so it's 3 plus 1. Hence 3 plus 1. So you got Manhattan distance as your distance metric, which is fine. That's, I guess, it's just to make it a little bit easier. Don't have to do any Euclidean squaring, square rooting, or anything like that. So you have distance that, and then yeah, minimum distance to type a word. So if we look at an example, oh yeah, the other thing is the initial positions are free. So like where you choose to place your fingers at the start doesn't cost any distance. And also you don't have to start on the first letter or the first two letters necessarily. I don't know why you wouldn't start on the first letter, but first two letters, I think the very first example from memory shows an example where you wouldn't put your first finger on C and your second finger on A. So, for example, if the word is equal to cake, right, then what you see is like, okay, I could put my first finger here, and then I could move it to A. That gives you 2. And then you could also put your second finger on K, and then type that. Move up to E, which is distance 1. So you get a 3. C, A, and then K, E. And that's how you get a 3. Now, if not for the fact that that example was written out already, in my mind, I would have gone C and A, just as my pointers, and then maybe I would have gone K and E. But the issue is 1, 2, 3, 4. So the amount of distance I travel there is, you go 1, 2, 3 to get to K, and then another 1 to get to E. So you traveled 4 that time. So greedy, or like just putting your fingers on the first two letters, isn't going to work. And the other sort of way greedy doesn't work is, imagine you have a word like A, F, X, F, 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 F. So again, greedily, what I would think is put one finger here, type the A, put one finger here, type the F. Happy days, right? Now, by pure greedy, if I have to type the X, I would think that I'd have to move the F down, because this finger is closer to the X than this finger, right? But if I type that like that, I have to go back to F like that, which actually might be worth it, actually. Wait, what's another example? Maybe if it's like V instead of X, if it's V, because 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, yeah. So here, you would go 5 down and 5 up. Whereas here, you would only go 6 down. 1, 2, 3, 4, 5, yeah. So after AF, if you choose to move this finger once and twice to go back to F, or maybe it's better to go 1, 2, 3, 4, 5. Well, regardless, basically, in conclusion, greedy doesn't work because there are instances where you would rather not move one finger over and over again. I think a better example would be if you had like AF and then like VFV, or maybe W. AF, XF, XF, XF. That's probably a better example, actually. Because then, yeah, it would obviously be better to invest a bit of extra distance into moving this guy over here rather than moving one finger back and forth over and over again, even if greedily this seems like a short distance. Like hitting AF and then going XF, XF, XF like that over and over again is way worse than if you do AF and then move this guy over here and then do XF. Like, then there's no distance to travel, right? So yeah, in conclusion, after all that, conclusion is greedy prioritizing the short distance in the moment doesn't work, which is good, because honestly, when I first read it, I was like, surely greedy would work, and then I was like, oh no, it doesn't. And yeah, the fact that it's only 300 characters in the word is indicative that greedy probably doesn't work. So this is basically where I got up to, except for in my head, I was thinking like, okay, I guess the way I can think about it is, initially, my fingers are like in the no man's land, like they're not on anything, right? Then from there, in the example of cake, I would either move my left finger to the C, or I would move my right finger to the C, right? I think in this particular instance, it wouldn't really matter which finger I move, so they're kind of symmetrical and therefore not really important, but whatever, just bear with me, right? From there, I have to go to the A. So either my left finger goes to A, or my right finger goes to A. And then a similar idea here. My left finger go to A, or my right finger. Or my right finger to go. Yeah, so it's actually like a symmetric tree. So maybe I only care about one half of it. And then from there I have to go K. So then it could be like K dash or AK, or it could be KA or CK. Then we have E, where it's like either E dash E or KE, or it could be like EK or AE, or it could be blah blah, right? And finally, all of these guys probably, I guess, eventually hit like a source, a destination. And then they would these edges would be weighted to 0. This edge would be weighted to 0. This would be weighted like 2. This would be weighted as 0, because in this, my pointer had to move 2 to get to A, from C to A. Here, my A came from no man's land. My finger went from no man's land, so they weighted 0. And so you could weight it like that. Going from A to K is like 1, 2, 3, 4, 5. Whereas this is 0. Going from C to K is like 1, 2 is 3. Going from A to K is 5. Right? So like, there's ways of, so I can basically build this tree kind of thing. This tree directed graph thing. Directed acyclic graph. DAG. However, in this naive approach, I sort of knew that there would be an exponential number of nodes because I'm doubling each time. An 8. 1, 2, 3, 4, 5. And despite my best efforts, 2 to the 300 is very big, right? So that's not going to be a fair time complexity. So like naively, I could try and build this tree, right, for the particular word, and then do like Dijkstra to figure out which has the shortest distance to get to the destination. But unfortunately, complexities, like the constraints, do not allow it. However, we also notice that I think there's a lot of like redundancy, right? Like we said that this entire branch here doesn't really need to be there. And then from there, you have CA, like okay, maybe these two have to be here. But then like, you have an AK and a KA. Or maybe like, you have a weight of 5, or I don't know, actually, maybe the rest of it isn't redundant. What I was thinking was like, if I think of all like the pairwise interactions, I might be able to draw it like a grid instead of like a tree. Because like, imagine I have my starting state, dash dash, and then like, I draw a grid like this, C dash, I'm gonna need way more space, C dash, A dash, K dash, and E dash. And then I have dash C, dash A, dash K, and dash E. So these are like the states that I could be in, where one finger is in no man's land and the other finger is on the key, right? So this is like as if I typed it, if I was to like move across the graph in this direction, it's as if I just moved one finger. And if I move down this column, it's as if I just moved the other finger. From there, I think I have like n squared states. I have like CC, I have AC, I have KC, and I have EC. I do that each time. CA, AA. I think the AA is kind of stupid, but anyway. Like I feel like if you're on the same key twice, that's kind of dumb, but we'll just roll with it for now. KA and EA. And then you have C, K, AK, K, oh, and EK. Last row you have CE, AE, KE, and EE. So in my mind, now we have roughly n squared kind of states that we can be in, right? Because I made a table that's like n plus 1 by n plus 1. So from there, like, if I was to say, okay, from here, I can either move one finger to C or I can move the other finger to C, and I weight it as 0. Here, I should move to the A state. I should get hit an A. So I either go here or I go here with a weight of 0 and 2. Here, I can either go, I need to go to the K state, so I either go here with a weight of whatever, 5 or whatever. A to K, right? 1, 2, 3, 4, 5. Yeah, 5. Or I should go here. Whoops, it's a bad edge. Here, I'll draw it like this. Here, with a weight of 0. Again, because from no man's state to K. And then here, I should go from K to E, which is 1. Or I can go down like this. Which is 0, yeah, sorry. And then E should basically, oh, I need like a destination node. And I think all of these can hit the destination node. Because like, they all sort of get to terminate. And they all have a weight of 0. Because I've basically completed, right? Now, I think every node has 2 edges. I probably don't care about these actually, because I don't think I'd ever use the same, like both fingers on the same key. So if I'm at AC, I need to go to a K state, so I should either go across, going from A to K, or I should go like this, shouldn't I either need to move this guy to K, or I need to move this guy to K, keeping A the same and changing C, or keeping C the same and changing K. So I believe that I can construct like an accurate graph. A to C, A to K. What was that weight? Sorry, A stays the same. C to K, sorry. 1, 2, 3. 5. And then I need to go to E at this point, so I either go here, changing the K to an E, which is 1, or I go like this, C to E, which is 2. And etc, etc. This terminates, all these terminate. What am I left with? I've done this node, this node, this node, this node. I've done this node, this node, this node. I did this one. How come this one never gets... I guess because KC and CK are like the same, kind of? Maybe I only care about like the top half of the triangle. So KA, I need to go to E. I either go across. K to E is a distance of 1. Or I go down. I'll do it in like a different color. I'll do it in black. I go down here. A to E. Do I know that one? Probably not. A to E is a distance of 4. Right? And that'd be it. So basically, I have n squared nodes, and I have 2 n squared edges, right? Or maybe I have half n squared nodes, and because each node that I choose to use basically has 2 edges that gets drawn. So I have double the number of edges as nodes. Maybe it's half n squared if I don't care about the bottom half. But maybe I do care about the bottom half. Okay, we'll say n squared then. N squared nodes and 2n squared edges. So like going from CA, I have to go to CK, which sort of jumps over. This one goes over here. Or goes down like this. And then I have to go to E state, which is either here, or I can go like that. I wonder if it's worth, like, instead of doing that, I wonder if it's worth, like, joining CA to AC with a distance of 0. Because, like, surely, like, they're symmetrical, right? It's the same idea, it's just which fingers you're using. So the distance to get from here to here would be the same as the distance to go from here to here. So maybe all of these should be joined like this, with a distance of 0. Would this work? Because what's Dijkstra's his time complexity is like, is it v plus e log of v, right? Because it's like going through every vertex and edge, and this is like, every time you do that, you also have to do the min heap stuff, like using a priority queue. So I think that's log. So then you got like n squared over here, log n squared, which should be fine for 300, right? You have 300 squared times log 300 squared. 300 squared times, how do I do log base 2? Does this work? No? Log 2? Ooh, 1.5 million. Is that too much? Is that really? What's 300 squared? 90,000. Maybe I did it wrong. Maybe that's not. If I'm log 2. Oh, right. No, that's why. Okay, I'll just do this then. So that times should be fine, right? I have no idea what the base is. I assume it's base 10. I don't know how good this is at. Oh, it is a hard 1.5 million. Oh. But also said log 2. Okay, no, it is right. Okay, fine. Okay, 1.5 million. That's a bit scary. I mean, it's like, it should be fine. 10 to the 6 is normally fine. Okay, I guess we can try that. Damn, this is pretty involved though. What a graph I have to build, right? Okay, so what do I need? I need a data structure that lets me okay, so I need, like, I guess a grid of nodes would be good. Which time? Okay. Grid of nodes. Maybe a class for nodes. And then where you have like your state. I also have to think about duplicates, don't I? Like, what if you have CA, K, and then like another A, like these two different A's? I don't know if that would affect things. Maybe not. Maybe I'll just say CA, KA, and it's fine. Maybe I'll make the grid as the normal and nothing bad happens. State. So yeah, call this state. Maybe like the maybe like your progress. in the sense of like, okay, at this point you've completed 0 letters. At this point you've completed 1. At this point you've completed 1. At this point you've completed 2 letters. Here you've completed 2 letters. Here you've completed 1 letter. Here you've completed 2 letters. Also 2 letters. Then you have like 3 letters, 3 letters, 3 letters, 3, you know? Like, you should be able to, I guess, determine how many letters, because that way you can figure out what the next letter should be. It should be all the other, it should be the progress plus 1 nodes that share a same letter. Like, to go from AC, I know I need either KC because progress plus 1, and also it has a C, so I've only done one move. I've moved the A to K. Or I should go K, so I should either go KC or AK. So these are my 2 neighbors. It's like a way of, like, I think the progress will help me figure out what my neighbors are. Yeah, that should be fine. And then I might need some other stuff. I will ignore that for now. Maybe like a hash table. Where like each key is the progress or something. Oh, construction is annoying. What do I even want? Because like figuring out exactly, I need a system to figure out where my neighbors are, because it's not necessarily as obvious as just going cross and down, because how much you have to go down by changes. So let's say, yeah, I make this node and it has a progress of 0, and then I make the C dash node, sorry, which has a distance of 1, or progress of 1. I also make the dash C node, which has a progress of 1. So what if I do like almost like a DFS kind of thing, where it's like, okay, I make this state, that's like my source, and then I say, what do I say? Maybe I make a destination as well. This is my destination. Progress is N. And I was like, okay, maybe I put it there. Like maybe I put it in a queue. This is purely for construction. So I put dash dash in a queue. Yeah, so BFS, not DFS actually. Put it in a queue, pop it off and say, okay, what should my neighbors be? And it's like, it's either the dash C or the C dash. Because I know, like by the progress, I know that I've done no letters. So I need to put the C first. So I'll make neighbors, like I'll make nodes like that. I'll make nodes like that. And then, so Q is dash dash. It creates a dash C and a C dash, which both get enqueued. And then from here I get I'm worried I'm getting exponential again. AC. Okay, what if I just do double for loop for I in range N, for J in range I plus 1 up to N. So the current state would be the word at I, the word at J. Maybe I don't want it to be I plus 1, maybe I just want it to be N, because I want both ways. Current state is that. The neighbor would be the states Wi plus 1 Wj and W where progress with the progress of progress plus 1, and the other neighbor would be wi wj plus 1, also with a progress value of progress plus 1. So you find those two nodes. So I guess we'll build it backwards. We'll start with... Wait, no, that doesn't make sense. Maybe it does make sense. Because progress goes 0, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 2. Oh my god. This is such a mess. How do I build this graph cleanly? How much time? Okay. I'm just trying to avoid exponential logic as well. I just need to, based on a particular thing, I just need to be able to find its neighbor nodes really quickly. Look for progress 1. This is progress 2, this is progress 2. This is progress 2. This is progress 1. This is progress 3. And this is progress 4. I was meant to change colors then. This is progress 4. Making such a mess. But I think, okay, well, maybe this makes it more predictable. Like, I know for sure that my neighbor should be to the left, sorry, to the right by 1. And it needs to also be beneath me by 1. Like, each neighbor is always to my left with 1 progress and down by 1 progress. You know? Like this guy, progress of 2, so I need to go across, and I have to go down until I get into this banner, progress of 2. So this is quite predictable, right? It's actually quite a predictable thing. I should be able to use math to do this. 1, 2, like I have to go down by 3 and across by 1. Here I have to go down by 4 and across by 1. Here I have to go, well, this is the diagonal, down by 1, across by 1. Down by 2, across by 1. Down by 1, 2, 3, across by 1. So maybe I just need to keep track of each progress change. Oh, I don't know. Progress is 0, 1, 2, 3, 4. This is wrong, hang on, sorry. Progress 0, 1, 2, 3, and 4. So if I'm at progress 1 and I want to get the progress 2, I should go to column 2. If I'm over here and I want progress 4, I should go to row 4 beneath me, and I should go to column 4 across from me. Does that work? If I'm over here and I want progress 3, I need to go to... Okay, maybe this is fine then. Yeah, I just need a grid of nodes. Like these are my... Oh no, this is why it's a problem. Because this is progress 2, not progress... Well, Wait, does this work? Wait, so this is progress 2 right here. So if I want progress 3, I go down to row 3. If I want progress 3, I go across to column 3. Huh. So if I literally just fill in a grid with all these nodes and their progress values, just progress 3, column 3 and row. Okay, maybe this will work. So my grid nodes is equal to, so n is equal to the length of word. My grid nodes is equal to, so it's 2-dimensional. I need 1, 2, I need 1, wait, 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. 2, 3, 4, 5, 1, 2, 3, 4, 10, 15, 20, 25. So I need n plus 1. So I need none for in range n plus 1 for in range n plus 1. 1. So we have the space, and then I think what I want is for I in range 0 or even -1? No. Maybe, yeah, -1 up to n. For j in range -1 up to n. This is progress 1 if I want to go to progress 2, I go here. This is progress 2 if I want to go to progress 2, I go here. This is progress 2 because it's in column 2. Even though it's in row 0, it's in column 2. So your progress is dependent on the bigger value between your row and your column. Okay. Your progress, yeah, that's what this is going to be. The maximum between I and j plus 1, or? I think so, yeah, because they'll both be -1 at the start, so you have to add 1 to say progress 0. If they're both, if I is 0 and j is -1, the progress is 1 because so it should be plus 1. God, this is very scary. The grid nodes at ij should equal I guess I make another class maybe. So I'll tell you state, def init, which is a string, progress, which is an int, and then self.state, self.progress, progress. Okay. So grid nodes at ij is equal to a node where the string is like, I guess, this is more for debugging than it is for anything else, but word at I followed by word at j. Fantastic. Also the progress, I forgot the progress. Plus the progress value. So we know how far it is. Self.neighbors is equal to nothing. Def add neighbor. Or add, neighbors. The neighbor, which is a node, and a weight or a distance, which is an int. And basically, is this fine? Can I do all this? Self.neighbors.append that particular neighbor with that particular weight. Okay. So I filled in the nodes, I have to fill in the... Wait, hold up, this can't be right. Can I just say 0 up to n plus 1? Why did I say minus 1? It's very strange. So no plus 1. Okay. So I and j basically refers to what my progress row and column values are. So from I to range n, for j in range n, because I don't really care about the lastmost grid yet in terms of their neighbors. The only neighbor that these guys have with the final progress value is the destination node. So I'll do that separately. Don't need to say 0 here. Okay. So for all these values, current is equal to the grid nodes at ij. Oh, wait. So this should be minus 1 because of that. Okay, but that might cause problems. So char1 is equal to word is equal to this if I less than 0, else should be word at I. Should be I minus 1, sorry. Char2 should be this if j less than 0, else word j minus 1. Just getting the characters. So then this should say char1, char2. Okay. So we get the current node, neighbor 1 is equal to... So moving across basically would mean I'm changing the left pointer, is I think how I wrote it, right? Like moving across... Oh no, the right pointer. Wait, what is... I've made such a mess. Okay. Moving across seems to mean that your progress 1 to progress... Sorry, progress 2 to progress 3... So that's to be able to figure out the edge. So I think moving across in the way I've set it up seems to mean that your left pointer is being moved. Your left becomes K. Whereas going down means your right. Is that how I set it up? Well, your J refers to your column. So I believe so, yeah. Or maybe not actually. I will be 0 for a while. J will increment continuously. So J will be changing. You've actually flipped it. I think this should be the other way around. Sort of confusingly, the way I've drawn it, I think it should say JI. Because basically I want, like, J is continuously increasing, which means J is progressing through the... Oh, no, wait, hold up. Oh, man, my brain's getting confused. So, like, this is I equals 0, J equals 0. This is I equals 0, J equals 1. It should say C and then dash, which means we want I to have progressed and J to have not have progressed. So yeah, we want the inner loop to be progressing, which means, yeah, J should be the column. Maybe I should just print it. And just return like 0 or whatever. What? We'll say +1, +1. That didn't really work. It's a lot of e's. I mean, that kind of, like the diagonal thing worked. Ah, sorry, not less than, equal to 0. So yeah, wrapped around. I got confused with my negatives and stuff. So I flipped it. I said -k, I can probably adapt to that, right? Okay, so this is what it looks like. And then so these are what my nodes look like. And then from there, I just want to be able to set my nodes correctly. So moving to the right means my right pointer is like changing. Whereas moving down means my left pointer, my left finger is changing. You'll see down the columns, like it's always K, or I shouldn't say that. It's A, and E, right? Like it's the same letter on the right side, and it's the left side that's changing. Going across, you'll notice that the first character is always the same, and the second one is what's changing. Okay, so moving to the right changes the right hand. That's a good way to remember it, actually. So I drew it wrong, basically, if anything. So that's fine. And then from there, how do I figure out my neighbors? Well, my right neighbor is equal to the same, it's my grid nodes, it's the same row, but it's the column from here, I think, right? Right neighbor is same, but with one more on the progress for the column. If this is my, so like if this is my if this is my node, I need to go one across. Okay. And my down neighbor is same thing, except current progress +1 for my row, and the same column. So for example, if this is the state I'm currently in, if I'm going to go down, my progress is currently 2, I need to go to 3. So I go 0, 1, 2, and 3, and that should give me the correct thing. Okay, and then distance is I have to be able to calculate distance as well, come on, don't I? Should I just make a big hash table for now? There's definitely smarter ways, but I just don't want to figure them out yet. Letter to position. Is this dumb? A, B. Nah, surely I can do this properly. Def calculate distance between C1 and C2. Both of them are 2 characters. So basically the way I see it is like, if I'm looking for like H to Q, I want to find them relative to A first, right? So considering there's 6 things in a row, there's 6 elements in each row, I guess how many groups of 6 are there to get to H? 1, so there's 1, if I was to do like order of C1 minus order of A, I think that's valid. That would tell me sort of how many characters there are. 1, 2, 3, 4, 5, 6, and 7, right? So this would give me 7. I think I floor that with 6, and I mod that with 6, and that should give me sort of my row number and my column number. And then same kind of idea with C2. absolute between row 1 minus row 2. I guess technically the col's the x value, so I'll do that first. Absolute value of col 1 minus col 2 plus this one. And I'll just add a constant being like num keys in row equals 6, just to get rid of the magic number a little bit. So in the edge case, let's say we were looking for z, difference would be 25. 1, 2, 3, 4, 5, 10, 15, 20, 25, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20, 21, 22, 23, 24, 25. I miscounted. Did I? Wait. Z minus A would give me 25, surely. Because 25 minus 0. Yeah, that's fine. So you get 25. So when you do, when you floor it with num, when you interdivide that with by 6, you would get, what, 4? Yeah, and you get remainder 1. So 0, 1, 2, 3, 4, 0, 1. I think that works. Okay, so we get, okay, so good. We figured that out. Right distance is equal to self dot calc distance, calculate distance between, so what did I say? Going to the right means it's the second thing that's changing. So you have to, oh, what I should say is if C1 equals to this, or C2 equals to this, then return 0. Because that means that you're in the no man's land. Yes, now calculate, what am I doing? Calculate the distance between your current dot state index 1 and your right neighbor dot state at index 1. And your down neighbor, your down distance, same vibe, except your current state at index 0, because it's these characters, index 0, and your down neighbor at index 0. So we have to add the neighbor, so current dot add neighbor, where the neighbor is the right neighbor, and the distance is right distance. And then in a similar sense, so I pray, based on all that, I pray that what I've done is built the graph. Oh. Spelled neighbor wrong. What? Oh, my bad. Tuple. Oh no. Oh yeah, I didn't really handle this very well. Oh yeah, and this was meant to not say +1. That was only for printing purposes. Oh, I have to do the destination node as well, don't I? Okay, cool. So yeah, now I'm not printing the E stuff. So the last thing I have to do is for, so everything in the last progress, maybe I can say +1. If current dot progress is equal to n, the number of elements, yes, then current dot add neighbor, I want like a destination node. Destination node is equal to node destination progress is, I guess, n+1, just to, destination node weight of 0, because I shouldn't, else, and then do all this. And then you can do your printing if you wish. Whoops, did I keep something? My bad. I have a very unfortunate sensation that I don't think this is how you're meant to be doing it, because I just feel like there's a lot going on. But I basically constructed a graph that I think is accurate. And then we just have to figure out what the shortest distance is from this node, where both fingers are on the free thingy, to the destination node. We just figure out the shortest distance. And we can use Dijkstra for that. You ready for this? Def Dijkstra. So I need my grid. I need all my nodes. I'll make a distance array in here. I need to make a priority queue, don't I? Oh god. Okay, so import heap pq. Grid nodes. I guess that's all I need, right? Source is equal to grid nodes. So that's the dash state. I need to make a distance array. I guess it'd be like a 2D array, right? Do I need a visited set? I always forget. So distance array. Okay, wait. So the number of nodes is equal to do I want the string? The length of grid nodes times the length of grid nodes, because you got 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So you got 25, and then plus 1. Plus 1 for the destination node, right? Cool. So num nodes is that. And then I need to make a distance array, which I think I can make like infinity. Can I do like this, times num nodes? I think that's how it works. So I make a distance array. Should it be 2D actually? I'm like flattening the list. I don't know if I should be. Well, I have a destination node which isn't part of the grid, so I don't think I can make it. I don't think I can make the distance array a grid thing. Unless I just terminate Dijkstra once it's finished all these nodes and don't bother with the destination. 0, 1, 2, 3, 4. Okay, well I should be able to translate your 2D coordinates into a one-dimensional thing, right? Because like you're 0, you're 1, you're 2, you're 3, you're 4. So if you're based on your ij value, I should be able to figure out your one-dimensional thing anyway. So it should be okay. I'm very scared. Priority queue is equal to this, and then like heap. I forget how to use this. Heap queue. Heapify, is it? PQ. And then it doesn't return anything. It does it in place from memory. And then heap queue dot heap push oof 0, I guess. Dist array at 0 is equal to 0. Yeah. And then what is it? While PQ is not empty. Heap q dot heap pop. The heap. I have to say what heap pop PQ current is equal to that. IJ is equal to, so from the current I can say current floor divided by I think it's this. So like if I'm over here, if I'm looking at this node, I'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So how many rows is that? Well, it's however many rows fit. So divide that by the number of cols. And I think mod by the number of cols as well. Which one was it? This one? 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it will be 11 if I 11 mod 1, 0, 1, 2, 3, 4 mod 5 gives me 1, 0. I think that's right, yeah. So now I have access to the corresponding node, like by doing that. I think I have to set it as visited, right? If current is in visited, then continue. Otherwise, visited don't add the current. I think I need a visited thing. From memory, I need one. You know when I push, I need to actually put the distance criteria in there. So we'll have tuples. IJ is that, grid node is that. We've marked it as visited. Current node equals that. For neighbor in I should probably put their coordinates as well, shouldn't I? Hang on. This might be helpful. Because I have the INJ already, I can easily look it up. Maybe you shouldn't say none, maybe it should be like, well, there's n+1 rows, so maybe the x should be n+1. I have reasons to believe that will work. Okay, so for this one in current node neighbors, but neighbors has a neighbor and a weight. If no. Flattened index for the neighbor is neighbor.coords at 0 times numcols plus neighbor coords at 1, I think. So like so I can access this, I can access the current distance. If if the distance at current plus the edge weight is strictly less than the distance of the, maybe just call it neighbor index, neighbor flat index, then this guy should equal this guy. I think I have to say heap q dot heap push onto PQ. I should push the new distance. And the neighbor flat index, right? It holds the, because the priority queue holds distance and the flat index. Is that it? I have to make sure I add to visited. I have to make sure I add to the priority queue every time I... While priority queue, and I think I can say distance array at -1 equals float infinity. Oh, maybe I shouldn't say that actually, no. Because this should eventually terminate because I keep popping, and visited should have stuff added to it if it doesn't have it, yeah. So this should eventually terminate. And then basically, the beauty of Dijkstra is if I return distance array at -1, -1 meaning the end of the array, which should refer to the destination node, this guy over here after all of these guys, that should give me my thing. Oh no. Return this one, self, given the grid nodes. All right, there's obviously going to be plenty of errors, but let's just see how many. I did not say grid chords. What? What do you mean? Built-in function or method object is not subscriptable. When did I try to subscript it? Oh, must have done something weird. Right. How many times did I write dist by itself? 1, 2, 3, 4, 5. I should say dist array. Crap. Ah, right, of course. Because again, when you heap pop, you're getting both the distance and the current flattened index. So it's there. Which means I shouldn't need to say this again, should I? Oh. Yeah, they should be equal. What? because when the idea is when you pop off the heat queue and it hasn't been visited, when you that action of popping is indicative that that is the best distance you can make for that node. That's the smallest distance you can use to get to that node from the source. So you should be able to use that distance as like the best distance. Oh, I'm scared. I really hope this is right. Oh, I have a none. Okay, I should stop now. Let me see if I can figure this out, and then I'll probably do like another video because neighbor chords at 0. Why would there be a none? Like, it's a for loop. Did I ever append a none? Oh, that could be why. No, but I'm accessing the neighbors. Like, I'm accessing this array. So I must have pushed none into here, right? Destination node, what did I make that? Like, it's not none, it's a thing. Should I do a bunch of print statements? Considering neighbor the flight index. Or maybe it's better just be like neighbor dot grid chords. Considering the neighbor at this point, yeah. Edge weight equals edge weight. Put a tab in there and I'll say next source at current dot set that, and then yeah, it should be fine, probably. All right, let's just see what happens. Is it straight away or what? Oh, it is straight away. So maybe I'm not the right neighbor grid nodes current progress. Current neighbor right distance. Down neighbor down distance. I'm very confused. Maybe I'll print okay, so it's dying there. So even the source isn't working. Unless I just never passed it in. Hang on. Because like it was a late thing I did, right? String progress and coordinates. String progress and coordinates. Yeah. Interesting. Where did it terminate again? Here? Let me just print ij equals ij. ij equals 0, 0. So the very first node, which was made here, the thing is, I'm able to print everything. So that shows that it exists. Like, what if I was today's current chords instead of current current state? What? Oh, it's called grid chords. Right? Is that why? It said node attribute. I thought it said none object. It says node object. Gird chords. Very silly. All right, let me turn this back into state. What happened? Ah, same issues. Aw. Five, 0. Okay, so that happens. 0, 1, 2, 3, 4. So the reason why that happened is because we're at the destination node. So we finally reached it. If I is equal to num columns 1, 2, 3, 4, 5. Then I guess we just break out. And for safety, I'll just say if j is also greater than or equal to num columns. It shouldn't happen, but just in case. Whoops. After this, sorry. Ah. Wait, did I say return 0? No. Ah. Edge weight seems to be 0 a lot. I don't really care where I am, I just want to see what the values are, because are they actually just 0? Silly goose. There you go. Yeah, okay. So the actual function is wrong. Cool. Okay, so what I think could be happening let me just make sure that, you know, it's actually running this function, because I'm a little bit scared that this is just happening every time. don't know what this printing is, but anyway. Excuse me? Brackets. Wow. Wow. I'm normally good with brackets. Completely forgot. I was so boiled up in like whether it would work or not, I forgot to actually write it correctly. But these numbers seem to be exactly the same. Also, it says -5, which is a bit insane. That doesn't make sense. A is the smallest it can get. How is it going negative? Zero, 1, 2, 3, 0, 1, 2, 3, 4, 5. Hold up. Print C1 equals C1. C2 equals C2. This is so much fun. Oh, bro, I'm so silly. I indexed 0 and 1, didn't I? Because I made the state a string. Okay, wait. I kind of forgot I'd done that. That was really a bit silly of me. Okay, so there's a couple of options. I think my best bet is literally just making it a tuple. I think that's more... I don't know why I made it a string, actually. Is that fine? char1, char2 is the state. Progress, ij is the position. And this one. So I need to make sure that... So instead of making it this... I don't know, space and space or something. Yeah. And then, yeah, state is a tuple now. And then hopefully, when I choose to get the current state 1 and 0, it should be, it should give me the right things now. Oh, it actually worked. Oh no. Okay. Does anyone have test cases that I can borrow? Oh! Wait, back up. Thanks, man. Appreciate you. Bing! Bong! Okay. What is that? Wow. Wow. What? Okay. What are the topics? I don't even know what's happening. I'm a bit tired, I think. I don't think I've got the mental capacity to figure out what's happening. DP? Seriously? This is a DP problem? Wow, my brain went straight to graph. Oh, it's like a 3D DP problem. Huh. Okay, I will definitely look at that. Oh, I know, I'm so bad at seeing DP ahead of time. I saw Dijkstra before I saw DP. Like, my days. Look at, oh, see, now I feel stupid. But what? Are you serious? You can DP this? I guess it's kind of like that shooting the walls problem with the robots. I don't know if I filmed that one. I maybe did it late, or maybe I haven't. Actually, I don't think I did it because it was like it was another DP problem that I couldn't figure out how to do. But they managed to use DP to like try without actually trying every case of like, oh, should you shoot left or right? There was a proof as to why DP worked, where you only had to know, you only had to test the previous robot shooting left and the previous robot shooting right. You didn't have to try all the combinations of left and right. So maybe it's similar. Like you don't have to try every combination of left and right for the fingers. You like kind of know ahead of time. But I'll definitely read the editorial or whatever. Someone's solution. Damn, I thought this was like conventional. I fully thought that this was like how you're meant to do it. Especially because the time complexity works out if you use a priority queue. Because I think Dijkstra, it's like over v squared if you don't use a priority queue. So then it would be like n to the 4 because v is equal to n squared. So then you'd have problems. But I thought the fact that I guess like 1.5 million was the number we came up with, right? Damn, I have to read through this, but I needed to eat and stuff. I need to do other stuff first, so I'll end this and then do